Alright, now we're going to model this item after inputting all of our stuff. I'm going to go ahead and make sure I'm on 3D model. I'm leaving the directions over here. If you don't want to use this video, the directions are step by step right here. You can do this yourself if you want. However, one more to note. I know it says in the directions, when finished, save the file, identify its name and location in your student folder. Please just turn it into the Dropbox when you're done. That's all I need you to do. So I'm going to work over here in this space right now. Step by step here, sketch a rectangle. Dimension the depth first, which is D0, and then the width. So I'll start a 2D sketch, bring up my area. I'm going to put this on the top because I feel like that's a little bit closer to what's going on here. So my top view. And with that, as I rotate around, I'm going to pan over here. My rectangle in the lower corner. Because we did all the work up front, we can just type in D1 and D0. So I'm going to type D1 for this, hit tab, do D0 for this, and hit enter. And that gives us those values. So I'm going to go ahead and finish the sketch. Rotate it around a bit so it looks a little bit more likely. Going to go ahead and go up to my create panel and extrude. Clicking extrude. Our profile is already selected. In this case, our extrusion is D2, so I just type D2 here. And the taper angle is D3, so back here, D3 and OK. So we get this nice little plate. We're going to come up to the top slot here. We have a few things, so I'm going to start a new sketch on the slot and let it rotate in. Panning it into C here. Now, slot is probably one that most people haven't done. If you hit the arrow down on the rectangle, you're going to see slot overall, slot center to center. There's a number of them. For this, we're just going to create a slot center to center. That's all we need to do. And I'm just going to click in here and place it. We click that way, and then we drag it out. Okay. So, D4 is our width. So as I go through and constrain this, endpoint to endpoint, D4. Okay. D5 is our location from this edge to this point. And D6 is our location from the top edge to this point. Okay. Finally, D7, the slot diameter, in this case, is what they're calling it. We just dimension that. And here we're going to pay attention to what things are looking like. I'm going to type in 0.25. And to me, that's looking similar to what we've got going on over here. As I zoom in on this, kind of difficult to see, but that's looking pretty close as an arc. So I'm going to go ahead and let that be. Whereas if that was a real diameter, if I did that, I think it'd be too small. So at this point, I can finish the sketch, extrude it, and we're going to do a cut of this profile. So I'm going to click the profile, and instead of extrusion, we're going to cut it, and we're going to extrude that a distance of D8, as we've already done that. Okay, one thing I missed there, sorry, I'm going to go back and edit the feature. On that D8, in the more, D9 is our taper angle, even though by default it is 0. We don't really need to worry about it at this point. Okay, we're going to sketch and dimension this other circle on here, so I'm going to start another sketch. Bring in a circle tool, click it in here. So, D10 is our whole width location. So, whoops, didn't grab constrain there. So this is D10. D11's the top to the center point. That's D11. And finally, our diameter is D12. Okay, so we've got our icon there. We're going to go ahead and finish that sketch. Extrude it out as a cut. Select the profile and cut. OK. So we've got our plate complete. At that point, you're going to go through and change the volume and the surface area. And then you're going to go through and change the overall plate depth to 1.5 inches. So rather than, remember, check the volume and surface area, right-click, Eye Properties, go to Physical. Then you are going to hit Update. I'm going to avoid doing that right now because I still expect you to be able to do this on your own. The other thing that you're going to do is you are going to change that overall plate depth, like I said. So what that means is you need to go into your parameters, that f of x on top, or Manage Parameters. And we are changing the value for D0 to be 1.5. And done. We're taking a look at what happened. So, describe what happens to the plate and the features when you revise that. In your own words, go ahead and write that out. It's obviously gotten a bit smaller, but some of the things didn't change. And then record those physical properties after it's resized. That takes you through the model. A couple of things to talk about on the conclusion. I do want you to do the conclusion question number 4. You need to go out and do a little research when using parametric formulas will be helpful. To know that, you're going to need to know a little bit more. So numeric constraint and geometric constraint. Geometric is essentially how pieces of the part are related to each other, whereas a numeric constraint really is our dimensioning. Okay, so what advantages to using formulas is that more advanced modeling, you can actually export in Excel files, and it will make a whole bunch of iterations of your different parts based on the parameters that you give it. So you can create a lot of different designs and tweak things as you need just by updating an equation. So that's a big time help on a lot of design. However, some of the disadvantages, you have to put in the time to set all that up. You really got to know what it is you're setting up. And you know, sometimes things just don't work parametrically. Okay, there's plenty of things out there where it's not helpful, and there's plenty of things out there where it is helpful. Your task at this point is to describe a situation in your engineering notebook in which using parametric formulas to dimension an object would be helpful. Go and put that in your notebook, save this file, turn it in to the Dropbox, and that's part 3 of the video. Good job, guys.